I've been running Kimi K3 through everything I can throw at it, and the numbers are genuinely wild. A 1M token context window that actually holds up, a 2.8 trillion parameter MOE architecture, a 91.2% browse comp score, open weights you can actually own, and pricing that puts it right up against the frontier. And here's the crazy part. Kimi K3 is open weight, which means you can run it yourself, self-host it, and keep your data off someone else's servers. On the SWE Marathon Long Horizon benchmark, it scores 42.0, which is ahead of both Fable 5 and GPT 5.6. Sol, and that's not a small thing. So in the next few minutes, I'm walking you through every real number I could find on Kimi K3, the benchmark scores, the real-world coding results, the speed, the control issues, so you can figure out if this is actually the model you should be building with right now, or if you're about to make an expensive mistake. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. I go through the official docs, the independent leaderboards, the community reviews, and I pull out what's actually true versus what's just launch day excitement. I read every comment on these videos, so tell me below, are you already running Kimi K3, or are you still on the fence? So, here's what's happening right now. The closed frontier models, Claude, GPT, are genuinely good. Like really good. Fast, reliable. They handle complex builds well, and you can spin one up in about 30 seconds with zero setup. For most people, that's a totally reasonable place to be, and I want to be upfront about that. But there's a massive problem. You don't own any of it, your prompts go to their servers, your data trains their models, and if they change the pricing or pull the API, you're stuck. You can't customize the weights, you can't self-host, and you have zero control over what happens to your code, which is exactly why open weight matters so much right now. Okay, so let's look at where Kimi K3 actually lands on the independent leaderboards, because this is the first thing you need to know before you put it in your stack. If it's not frontier adjacent, none of the other stuff matters, and the numbers here are actually pretty interesting. On the AA Intelligence Index V4.1, it comes in at around 57, which is 4th overall. Deep SWE with the Kimi code harness, 67.5%. Browse comp on Vellum's leaderboard, 91.2%. Terminal bench 2.1, 88.3%. The list goes on. I pulled these from every aggregator I could find, and the story is pretty consistent across all of them. The honest read here is that Kimi K3 is frontier adjacent, not frontier leading. Fable 5 and GPT 5.6. Sol are consistently a few points ahead on the AA index, and the deep SWE gap to the top two is about 3 to 5 points. So if you need the absolute best on every single benchmark, it's not quite there yet, and I think it's worth being straight about that. Alright, so benchmarks are one thing, but what actually matters is how Kimi K3 holds up when you're throwing real coding work at it, and this is where things get a little more complicated, because the gap between the spec sheet and the real-world feel is something you really want to understand before you commit. So here's how the different difficulty levels shake out. Simple GitHub issue resolution, Kimi K3 scores about 64 out of 70, basically on par with Opus 4.8. Complex builds, it drops to just above 60 out of 70, while Opus stays above 62. Engineered trap tasks, and this is the one that got me, Kimi K3 fails 36% of them. That 36% trap task failure rate is 4.5 times higher than Opus 4.8's 8%, and community reviewers are backing this up. They're seeing more instruction misunderstandings, worse decisions on ambiguous tasks, and more cases where the model just goes off in the wrong direction. On simple work, it's totally fine, but the more complex and tricky the task, the more you need to stay in the loop. Now let's talk about speed, because this one really matters depending on how you're planning to run Kimi K3. The answer is very different depending on whether you're hitting the API or trying to run it locally. And one of those options is going to surprise you in a way you probably don't want to be surprised. So when I first looked at the local inference option, I thought, another massive open weight model you can run at home. We've seen a million of these. But then I actually tried it, and yeah, on an M1 MacBook, it's about 4 seconds. Per token, that's not a typo. The API runs at 32.9 tokens per second with a 4.34 second time to first token, which is mid-pack, but totally usable. The reason local is so slow is that Kimi K3 needs around 720 gigabytes of VRAM to run properly. Moonshot themselves recommend 64 plus accelerator supernodes, which is data center territory, not a home lab. If you want speed on the API side, community members are reporting 163 tokens per second on Fireworks. So that's the practical path here. Real quick, if what you've heard so far is already useful, go ahead and subscribe, because the next video builds directly on this and gets into how to actually set up the API workflow so you're not wasting tokens on every call. Takes 2 seconds and you won't miss it when it drops. Okay, so here's the one I think is the most underrated thing to understand about Kimi K3 before you put it in a production workflow. It's designed to be agentic. It reads files, edits code, executes commands, and decides what to do next on its own. That sounds great on paper, and in some cases it really is, but there's a real cost to it that you need to know about. So I tried building a small automation with Kimi K3 through the API, priced at $3 per million input tokens and $15 per million output tokens. And here's what I noticed: because max thinking effort is the only mode at launch, every single output is billed at the full output token rate with no lightweight mode. So a task that loops back 3 or 4 times, which users are reporting happens a lot, adds up fast. Community reviewers are describing it as the model tweaking and changing things way beyond scope of what they asked for, and looping back over tasks it already finished. For exploratory work where you're watching it, that's kind of fine. For a production pipeline running overnight without supervision, that's a real liability. And it's something you want to go in with your eyes open about. Alright, so now we get to the thing I think is Kimi K3's single biggest actual advantage over pretty much everything else out there right now: the 1M token context window. And I want to be specific about why this matters, because a lot of models claim big context windows and then fall apart when you actually use the full thing. Okay, so the official spec is 1,048,576 tokens. That's the model card number, not marketing. And at full context, it holds 90.4 accuracy with no context management tricks. On SWE Marathon, which is a long horizon agentic coding benchmark, it scores 42.0, ahead of Fable 5 at 35.0 and GPT 5.6 Soul at 39.0, and that's a real verified lead. The important caveat is that even with a 1M window and strong long horizon scores, Kimi K3 is a pair programmer, not an autonomous agent. It needs steering. Multi-file refactoring works really well, and for module-level understanding of a large code base, it's honestly pretty impressive. But if you hand it a long task and walk away, you're going to come back to something unexpected. So here's the real picture. People not using Kimi K3 are hitting context limits and losing module-level understanding on big code bases. You're loading 1 million tokens and holding 90.4% accuracy across all of it. They're getting beaten on long horizon tasks by models they're paying closed source prices for. You're scoring 42.0 on SWE Marathon and actually owning the weights. They're locked in, and you're not. Kimi K3 does fall short in real places though. Complex builds drop to around 60 out of 70, while Opus 4.8 stays above 62. The trap task failure rate is 36% versus 8%, which is a 4.5x gap you can't ignore. And local inference on consumer hardware is basically a non-starter at 4 seconds per token. I want to be straight with you. Nobody's paying me for this, and I have no relationship with Moonshot or Kimi at all. So here's what you should do. 1. Go to kimi.com right now and pull up the API docs. Look at the pricing page, confirm the $3 in and $15 out per million tokens, and figure out what your actual workload would cost before you write a single line of code. 2. Find one large codebase you're already working on and try Kimi K3 on a real context-heavy task today. Something with multiple files. 3. If you want faster output, look at Fireworks as your inference provider. Community members are getting 163 tokens per second on Fireworks versus 32.9 on the official API, and that's a real difference in feel. 4. Do not hand Kimi K3 a complex, ambiguous task and walk away. Stay in the loop, especially on anything that touches production code, until you know how it behaves in your specific setup. Within 2 years, I think open weight models with real 1M token context are going to be the default for serious coding workflows. And the people getting hands-on with Kimi K3 right now are going to have a massive head start. The 1M context that holds 90.4% accuracy at full window. That's the thing to take away from this video, and you're early if you start today. If this was useful, hit like and subscribe. The next video gets into exactly how to set up an agentic Kimi K3 workflow with the right guardrails so you're not burning tokens on loopbacks. And that one's going to save you real money, so you don't want to miss it.